6. Come on, hot one. Come on.
We've got some information we're going to cover in the first part of class. Some information we're going to cover in the first part of class. And then we're going to have because this class time's a little longer, I better short video. Hannah? It's my turn.
All right.
And then we're going to, there's a short video I want to show you, about 10 minutes, that the classes didn't get a chance to see. That talks a little bit about the periodic table and its development, but I think says some things and some information that would be very useful. And then the additional time, some of the time I want to give you to actually work on the homework that the other classes didn't get to do. So I'm done with attendance here.
So you're talking about the 14.2 sheet?
14.2, yeah. Give you a chance to read through that and work on that. Okay.
14.2.
Okay. It's very short, but I want you to get a piece of line paper or your notebook, wherever you're taking notes, and I'm going to add to that just a little bit today. But rather than make you draw the diagram of the periodic chart, I'm going to make it easy on you and also draw. Okay. Okay. You don't need your book open right now. Okay? I just said you're going to have some time to work on the homework in a bit. So go ahead and close. Go ahead and close your book. Alex? So in 14.1, we're talking about the arrangement of the periodic table. And talked about this a couple of times. Well, how is the periodic table arranged? What determines how those atoms are being put in all the orders that they're being placed in? Their particular positions. So part of it is arranged by the number of protons. The number of protons being the atomic number. So they're arranged by increasing atomic number. It's arranged by atomic number. That's one way it's arranged. How else is it arranged? What's that, Dylan?
I said very neatly.
Very neatly. I agree. It is kind of neat how it's arranged. And all the different information makes sense when you start to understand it. It's kind of neat. I'm not sure that's what you meant by neat, but I'll take
I
it.
think you meant neat and tidy.
Neat and tidy.
Is that what you meant?
Nolan?
Like by noble gas and metalloid and I guess so.
Okay, so we see some patterns in their physical characteristics as to whether or not they are metals or metalloids or non-metals. Would you see that pattern emerge? What else?
The amount of electrons.
We are arranged by the number of electrons, which in a neutral element is equal to the number of protons. Why such a strange shape? Why not just a box? Like 17 wide and 6 down or whatever, instead of having these different areas. what's interesting is, and actually kind of ironic, is that while the protons and the neutrons make up essentially all of the mass of the atoms, they don't really have much to do with the actual physical and chemical properties of the atoms. But the electrons, they're so incredibly small, have so little mass, actually have far more to say, or far more effect, on what an element reacts with, what compounds it can form, than the protons and the neutrons are. Remember how small these are? And we're talking about, when we add up the atomic mass of an atom, the number of protons and neutrons, we don't even account for the electrons. Even for a really large atom, like, there's 79 protons and whatever number of neutrons, and there's 79 electrons matching. Even when you have a large number of electrons, there's not enough mass there to worry about. I think I used the example, it was like the mass of a speck of dust versus the mass of a school bus. The dust being the electron and the school bus being a proton or a neutron. If you add one more speck of dust on top of the bus, did the bus gain mass? Well, technically, yes. But is it noticeable? Is it measurable? Not without some incredibly sensitive equipment. The electron and the electron configuration is what determines the chemical and physical properties of an element. The chemical and physical properties of an element. So the periodic table is really arranged in a way that accounts for the electronic configurations. Listen, please. Accounts for the electronic configurations. So, I gave you a handout. So we're going to add the rest of our notes today. We're going to add right to this sheet. This says patterns in the periodic table. And just the top half of that. So let's start in the upper left-hand corner and understand the patterns that emerge. Justin? Yeah, he said he thought he had it. So, what element are we talking about here in the very first box? Hydrogen. Okay? No, I'm not going to have you fill in. Just I'll show you what I want you to put in there. Hydrogen. What is the electron configuration of hydrogen? It has an atomic number of 1. What's that? 1s1. Now, what do you call the different rows of the periodic table? What are those called? They're called periods. So first of all, I want you to number the periods 1 through 7. Number those 1 through 7. So in the case of hydrogen at the very top of this first column, it's a 1s1. I'm just going to put S1 in that box.
Is that what you want us to do?
That's what I want you to do. So anything that I add today to this diagram, I'm asking you to also add to yours. Okay? So this is a 1s1. What do you call this column of elements, by the way? It's the name of just this column. It's a groups or family. Okay, let me ask you this question. What's the name of these? This column, this group. What? Noble gases. Okay, what's the name you give to this one?
Noble solids.
Wrong.
Alkaline minerals.
They're called alkaline minerals. The next column is similar in name, but it's 3 words. Alkaline earth metals. Okay? Remember, these here and these here are referred to as the representative elements. What are these referred to as? The what?
It's just
The what? No, the representative elements are these two groups. What are these called?
Transition.
Transition. What are these called?
Inner transition.
Intertransition metals. So if we look at this, 1s1, what's the next element after hydrogen? What's number 2? Helium. It's actually over here. What is its electron configuration? 1s2. I'm going to put an s2 in here. Now, helium's kind of placed in an odd spot. We'll talk about that in just a little bit. Because it really can almost occupy 2 spots in this periodic table. You can't put it in twice. After we do 1s1, 1s2, what's the next energy level? Uh-oh, we need our off-ball diagram. 2s. So we have 1s2, 2s. This would be a 2s1. Look at this. Second periodic, second period, second energy level, S1. So the outermost, the very last electron, because interesting enough, remember I said it's the electrons that determine the chemical and physical properties? It's not even all the electrons. It's the outermost electrons that determine those things, not the ones like in a very large atom that are closer to the nucleus. It's the outermost ones that determine it. So it's not even all of them. So the outermost electron here is a 2s1. Kind of like a battleship here. Row 2, it's an s1. What's the next one? That's lithium. What's the next element after lithium? Beryllium, Be. That would be 2s, 2s2. Go down to the next row here, sodium. You want to take a guess at what the outermost electron configuration is for sodium? 3s1. This s1 follows everyone all the way down this column. The s2 follows down this. All of the elements that have s1 as its outermost electron is in this first column. They are called alkali metals. So if we look at this one, I believe this is francium on the periodic table. Okay, Fr, francium. But what is its outermost electron? Which S1? 7, S1. I think you sunk my battleship. It's not like battleship, isn't it? Yeah. You can't talk. Okay? This is going to be a 7, S2. Because